All right, let's dive straight into this explainer and seriously upgrade your mathematical arsenal for tackling algebra and sequences. Today, we're taking some of the absolute most fundamental concepts from your math curriculum, linear equations, quadratic roots, and arithmetic progressions, and organizing them into a highly effective mental toolkit. We aren't just memorizing formulas today, we're learning exactly when and how to deploy them in the wild. Here's our survival guide syllabus for today: the patterns around us, cracking linear equations, master and quadratic roots, arithmetic progression basics, some very cool Telugu math cheat codes, and finally, the master formula matrix. Section 1, the patterns around us. So let's start with reality, not just chalkboards, to see why we actually need these tools. Have you ever wondered how we can accurately predict when a cab is going to arrive in moving traffic? Or exactly what your savings will look like in 5 years? It sounds like literal fortune telling, right? But honestly, it's just pattern recognition. When traffic moves at a constant speed, or you stash away cash, you're generating a predictable sequence. Like if you decide to save an extra 100 rupees every single month, 100, then 200, then 300. You are literally living an arithmetic progression. Or think about urban planners. When they map out streetlights exactly 20 meters apart, they're using these exact same mathematical sequences to design safer cities. The math is everywhere around us. Section 2, cracking linear equations. Now that we see the math out in the real world, let's crack open our toolkit. A linear equation has a degree of 1, meaning there are 0 squared variables. Geometrically, it represents a perfectly straight line. The absolute crucial takeaway here is understanding the difference between finding that one single point where two straight lines cross, which is what linear systems do, versus finding the roots of a curved parabola, which we're going to tackle later with quadratics. Let's get into the actual mechanics and see how this builds into two foolproof methods for solving any linear system. First up, the substitution method. It's kind of like a magic trick. You isolate y in one equation, plug that entire expression into the second equation, and boom, you magically reduce it to just one variable. The elimination method, on the other hand, is a bit more aggressive. You multiply the equations by constants until the coefficients match, and then you just add or subtract them to wipe a variable completely off the board. Both get you to that exact same intersection point. But knowing the algebra is only half the battle, right? You've got to set the problem up correctly. If you get hit with one of those classic boat speed word problems, this upstream-downstream setup is your absolute best friend. Assign x to the boat's speed in still water and y to the stream's current, and you've got a perfect linear model. Cruising downstream, the water's pushing you, so it's x plus y. Fighting upstream, the water holds you back, so it's x minus y. Master this setup, and those word problems are literally a breeze. Section 3, mastering quadratic roots. Okay, we're leveling up to second degree of polynomials now. We're leaving straight lines behind for the world of curves. Every single quadratic equation you face can be boiled down to this really elegant standard form: ax squared plus bx plus c equals 0. Now, a cannot be 0 because if it is, well, that squared term vanishes and you're right back to a linear equation. This form right here is the starting line for everything we do with quadratics. And hidden inside that famous quadratic formula is this absolute gem. This specific chunk is called the discriminant, and it completely dictates the nature of your two roots. Just by evaluating b squared minus 4ac, you instantly know if your parabola crosses the x-axis twice, maybe just grazes it once, or floats above it entirely with no real roots at all. It's basically a crystal ball for your equation. Now, what if you want to work backwards? If you memorize these relationships between the roots and coefficients, you can often skip that giant quadratic formula entirely. If you know the two roots, let's call them alpha and beta, their sum is always negative b over a, and their product is c over a. Even cooler, if a test gives you the roots and asks for the equation, just plug them into this template: x squared minus the sum times x plus the product equals 0. It is incredibly efficient. Section 4, arithmetic progression basics. Let's shift gears to our third tool, arithmetic progressions, or AP for short, which are all about predictable stepping stone patterns. The total lifeblood of any AP sequence is d, the constant common difference between any two consecutive terms. It's just the current term minus the previous term. Whether you're counting the stairs you climb or calculating a fixed weekly allowance, that constant jump is your d. And remember, it can be positive, negative, or even 0. With these formulas, you can basically time travel to any position in an infinite sequence, or tally up massive lists of numbers instantly. Need the 100th number? Take the first term a and just add 99 jumps of d. That's your nth term formula. But if you need to add all those numbers together, Use the sum formula. Oh, and here's a brilliant shortcut. If you actually know the very first term and the very last term, just average them and multiply by the total number of terms. Done. Section 5, Telugu Math Cheat Codes. As promised, time for a little bilingual pattern interrupt. Examlo time save chainaniki. To save some serious time in your exams, we're going to look at some classic shortcuts framed with traditional Telugu terms. First up is the Rahasya Margam, which literally means the secret path. Question low, sum of 3 terms in an AP uneasda. If a question gives you the sum of 3 terms in an AP, do not use X, Y, and Z. Assume they are A minus D, A, and A plus D. By taking this secret path, those common differences magically cancel out. Add them up and the minus D and plus D instantly vanish, leaving just 3A. Chala simple trickity. It's a stunningly fast route to the answer. Next, we've got a fantastic chitkalu, which translates to a clever exam trick. Muru consecutive terms on day. If you've got 3 consecutive terms in an AP, let's say A, B, and C, you absolutely don't need complex formulas for the middle one. The middle term is literally just the exact arithmetic mean of its 2 neighbors. Just add the first and third terms, and renditini divide by 2 cheyandi. Divide the 2 by 2. Simple, elegant, and knowing these little cultural mnemonic hooks makes them way harder to forget when you're under pressure. Section 6, the Master Formula Matrix. All right, let's bring all these distinct tools, from linear systems to cheat codes, together into one single cohesive map. Take a mental screenshot of this matrix right now, because it perfectly aligns your mathematical goal with the exact tool you need to solve it. Trying to find where 2 lines cross? You're in linear territory. Need the roots of a parabola? Grab that quadratic formula. Searching for a specific position or the total sum of a pattern? Pull your AP formulas. In math, half the battle is really just knowing which tool to actually pull out of the box. Before we wrap this up, I want you to keep this powerful advice from the next Pro Tools guide in mind. Consistency beats intensity. Building mathematical muscle memory requires daily, steady practice, kind of like an arithmetic progression itself. You just can't cram a semester of complex problem solving into a single night. But 30 minutes a day of focused, consistent practice, that will wire these formulas into your brain permanently. And that brings us to the end of today's explainer. We've gone from predicting cab arrivals to mastering the Rahasya Margam of progressions. So look around you, spot the patterns, and keep questioning the math behind the universe. If you now have the tools to calculate the sum of infinite patterns today, what real-world problem are you going to solve tomorrow? Keep practicing, and I'll catch you in the next explainer.